So the first talk you heard about, are going to push things to the edge for sustainability reasons. So the energy consumption of the world is crazy, but also because of network availability. You have these devices in your home, and basically your broadband to get to the outside world, even if you have redundant broadband and you have fiber to the home and you have 4G and 3G and your neighbor's Wi-Fi is shared with you and so on, it's still not good enough to give you a decent availability. And then we heard about it's feasible to build these super small devices that do really pretty effective machine learning AI type applications on the device. We've been mucking around with that in a couple of projects in Cambridge. I don't have time to go into detail, but we have an open source library that does Edge AI that runs on Raspberry Pi computers, not quite as small as you just heard about, but still quite affordable. And of course, the original Pi had a GPU, which is exactly the sort of accelerator, sort of magic bit of hardware, which works really well for a lot of machine learning algorithms. So what we're going to say about the Edge AI case is that sort of re-decentralization movement is coming along because of availability. You want the systems to be available, and you want the trained system to be available in the home, and because of the energy sustainability, and because of privacy. You don't want to send the data anywhere. Why would you send half of your personal data to anyone ever? What is the point? As somebody said at the Royal Society recently, it was a Chatham House rule, so I can't name them, but they came up with this great quote post Cambridge Analytica, which is, data is the new fur. It's brilliant. So, if you move the data somewhere, well, why would you do that? Can't you actually run your machine learning in a decentralized way? And I've got sort of 3 little case studies to illustrate this. The first one is smart metering done right. Smart metering is kind of poster child for this. Smart meters send your meter reading used to be 30 seconds in the original design spec, pointlessly to a cloud provider. In theory, if they did it at 600 times a second, they could work out when you turned on and off your light switch, or work out when the fan goes on and off in your fridge or your fan oven. But it's pointless. There's nothing they can do about that. All they need to know is a model of what kind of household you are, so they can target you with better price offerings. And for that model, they probably just need a 16-bin histogram and know which one you are in there. So they can build that model in a fully decentralized way by running the machine learning on your smart meter. Literally, and it's not going to be a very big deal, because even if you read 600 hertz, the amount of processing you need to get your, what was your busy minute, your busy hour, your busy day, your busy week, busy so on, to compute that histogram for all the different houses, and then figure out what your energy production should look like when you spin up and down generators, and what the price should look like for your particular niche customers and so on, will work fine. So what is the issue there? That worked fine. And you didn't have to send the data to net, which meant you had to have network availability. You didn't have the creeping fear that the energy company was going to reach into your home and turn the lights off and knock you down the stairs, or some other bad thing. Philips Hue actually had a wonderfully scary bug where you could infect somebody worked out you could go viral over the whole of Paris in 10 minutes, control every light bulb and strobe them and cause epileptic fits. Philips, to their great merit, fixed the bug that day. Actually, it was a really cool fundamental thing that they fixed, so it was very good. But why would you have that world? Why would you have control over what's going on? So that's completely mad. Second thing we built as a sort of poster child example on Raspberry Pis was privacy-preserving face recognition. So without stealing lots of pictures off of the world, we run face recognition on the faces in your house. So presumably people don't mind you seeing their face. Okay, and we train up a neural net, a convolutional neural net, in the standard way, and then we share the parameters of the neural net. We actually, send a vector of the outputs to all the other neural nets, and we have a couple of different ways of doing that. And then the third one, which is obviously quite a sort of privacy invasive thing, would be compliance checking for people taking their medication, which is very important. You might want to share the compliance with your GP, maybe with a paramedic if an alarm goes off, but perhaps not with everyone in the world. So these are all kind of examples. You can think of many others. If you do all these things in the home and people are not worried about their privacy, they may allow you to combine data from multiple sources, like well-being and their healthcare data, or their financial and their drinks cabinet, or whatever, and all of the above. And all of these things together might be interesting to the people in the home. Why would it be interesting to somebody else? On the other hand, the overall aggregate statistics might be interesting to businesses that every now and then might want to be able to look at that. So in our world where we do a fully decentralized machine learning, we're not quite fully decentralized all the time. We have 2 different approaches. One I already mentioned, which is you have a model parameter server, and you send, if you're training face recognition system, you can send your big vector at each step of the iteration to there. There is an issue there, which is you can infer the training data from a semi-trained neural net. So we have a concern, which I'll mention how you fix that. We also have a fully peer-to-peer way of doing things, but then you have a scaling issue because you have if you have n nodes and at each iteration in training, you have n squared messages. This is not a good thing. So we have various ways of doing distributed sampling for that to make that scale. Our target kind of training system is if we can get 35 million households to have a Raspberry Pi each, and then we run that over that would be kind of cool. The kind of techniques you might have, if you're running stuff in a model parameter server, you have a server, you still have some cloud. It's not a big deal because all it is a parameter server. It's not doing much computation, but it might still be a point of attack on your data. So we would recommend using an enclave, like a confidential cloud type mechanism with Intel SGX or TrustZone on an ARM, or using homomorphic encryption. The operations are very simple in this world. You're not actually doing much with them. Or just normal encryption would probably work if you figure out the key distribution. If you're in the fully decentralized world, you still might worry about one of the peers being a bad person trying to join in and then just to get the data, which are the increments that are face recognition or whatever. Then you could, if you're really paranoid of that kind of application, you might build a multi-party computation with some kind of zero-knowledge system. So there are folks who've built some of those. They're high latency, but that's in the training phase, not in the use phase. That's not when you're waiting the 4 seconds for the thing to recognize your face, so it switches to the right Netflix account on your TV instead of recommending you the things your kids watch, which is what I get the whole time at home. Okay, so that's the kind of world we're trying to build. One point about edge is close to the edge is not enough. We heard about telcos. Telcos have been pushing edge computing for quite a while. What they mean is a land grab on the cloud. They just want the cloud to be just inside their network for 2 reasons. One, they want the money from what Amazon and Google and every people make. And 2, they want to stop the backhaul traffic going across the net pointlessly, in my view. But anyway, they're at least sort of moving some way to the edge. But of course, they still own access. And this is not acceptable for privacy reasons. Unless, of course, you do support enclaves and key distribution is right, or multi-party crypto done right, or homomorphic encryption, and then you control the keys and access. So that would then be okay. So actually there's a kind of path to re-decentralization, which is friendly to telcos, right? That they might put a small data center, small cluster in every cell tower and every DSLAM and every whatever, and then with the right key management, with the end users owning stuff, that's a good thing because the sort of canonical grandpa can't look after the computer, the Raspberry Pi in their home, but it's just inside the network. It's got most of the advantages for energy and availability, not all of them, but it has the privacy fix as well. Okay, so I'm pretty much done there, so I should shut up because I'm talking too fast and it's very hot in here. That's not helping. So.